Assalamu alaikum friends. In this video we are going to solve important example. This is draw shear and moment diagram for the compound beam shown. Assume that support A and C are roller and B and E are pin connections. So I already draw free body diagram. If you do not know how to calculate support reactions, then please watch previous lectures, because it is very important to first learn how to calculate support reactions and how to make moment function, shear force function. So I am going to draw shear force diagram now. I will make line of equal length here. So this is point A and this is point B after 10 feet, and this is point C here after 10 feet, and this is point D, and finally here is point E. First we will find shear force at point A. So I will write here this support reaction. This comes out to be 4K. This is 16, this is 16, so this will be 0. And at point C there is 45K support reaction. I will write here 45K, and at this point this is 6K. This is pin support and this is also pin support. These will give two support reactions, but I am only writing one because there is not any horizontal force, so horizontal reaction will be 0. And at this point B, summation of these forces will be 0. So here will be force in upward direction, that will be equal to force in downward direction. So we will start drawing shear force diagram. So we will start from point A. So in order to calculate shear force at point A, I will draw a sectional line which is very close to point A. Either I have to analyze now left side or this right side. It is easy. We will analyze left side, and we are using this sign convention. This is positive. If shear force on left side will be in upward direction, we will take this as positive. So this is an upward direction, so we will take it as positive. It is 4 pound. So I will go here that this is 4 pound. Now at point B, I will draw a sectional line which is close to point B. So this is in upward direction, this force will be in downward direction. So resultant will be 4 minus this magnitude is 20. So it will be minus 16. At point B, I will go down. This is minus 16. Now you have to join these two pointers. How can you join these? So you have to determine first slope. Now what is slope? What is slope of shear force diagram? Slope of shear force diagram is intensity of load, or slope of shear force diagram is load from point A to B. This load is in downward direction. It means load is negative, but load is slope of shear force diagram, so we will write slope of shear force diagram equals to negative. And slope is, this load is constant, so we will write slope of shear force diagram will be constant. So it means this will lie in second quadrant, because in second quadrant slope of a line is negative and we will make straight line, slope of straight line is constant. So this is a line which is in second quadrant, but it is straight. So this is at point B. Now at this point, which is 6 feet away from this B support, we will first make a sectional line on the this side, left side. So this force will be same, shear force will be same, that is minus 16. Up to this point shear force is constant, minus 16, which is 6 feet. I will go 6 feet and take shear force constant up here, minus 16. And at this point this is abruptly increasing from -16 to -21, because if I draw sectional line here, this will be -16 up to here, and at this point this is -5, so this will be -16 -5, that is 20 -21. So I will go down here, this is -21. Now from this point to point C, shear force is constant, so I will go here. At point C, shear force is constant, but at point C this is abruptly increasing. So if we draw a sectional line here, this is in upward direction, so this is positive, so this is increasing. So -20, -21, this is +25 40, sorry, this is +20 45, so this will come 24 at point C. So I will move here, let this is 24. Now at point this, first we will calculate shear force at point E. So we will make a sectional line which is close to point E. Either we will analyze this side or this side, so it is easy, we will analyze this side. So let we analyze this side. Shear force is in downward direction on the right side of sectional line, so it means this is positive, because it is matching to our sign convention, and its magnitude is 6. So this will be 6 here at point E. Shear force will be 6. Let this is 6 pound. Now if we find shear force at point D, we will make a sectional line just close to point D. So shear force will be due to this 6 plus this area. These are both in downward direction, these are both matching to our sign convention, so both we have to treat them as positive. So we will write 6 plus area of this triangle, this will be 1/2 base into altitude. Base is 6 and altitude is 3, that will be 9. 1/2, so that is 3 into 3, that is 9, so that will be 15. So at point D, shear force is 15. If I, so that will be somewhere here. Now from this point to point D, you have to draw shear force diagram. Now what we have, we find these values. Now we have to find slope. So how can we find slope? Shear force from point C to D, shear force is in downward direction. If we make section line here, this is in downward direction, it means our shear force is negative, sorry, our load is negative. Load is in downward direction, it means our load is negative from point C to D. So what is load? Load is slope of shear force diagram, so I will write slope equals to negative from point C to D, because load is in downward direction, which is negative, and this load is increasing in magnitude. Here is less, here is more, here is more, so we will write slope of shear force diagram is increasing in magnitude. Now from point this C to D, shear force diagram have negative slope, which means it will lie on second quadrant, and slope is increasing from point C to D. So how can we make that? First, it is clear that we have to make this is second quadrant, so it will be like this or like this. Now it is saying that this slope is increasing, so here will be less slope at this point, because here is load very less, so I will make 0 slope. So this will be less slope, more, and at this point this will be, at point D it will be more. So this is a line which have negative slope because it lies in second quadrant, and slope is increasing. You can see here it is more inclined, here it is less inclined. So this is line which have negative slope and slope is increasing. So we will make here this is a line which have negative slope and slope is increasing. Now from point D to E, load is also negative, So we will write from point D to E. From point D to E, load is negative. It means slope equals to negative. But here is magnitude of load is very more, then it is decreasing. Magnitude of load is decreasing. At this point load is high, at this point load is little, at this point it is very little. So we will write slope is negative, but magnitude of slope is decreasing. So how can we make this? It means at this point, at this point D, so this magnitude of slope is more, but this is decreasing. So how can we make this? It means if this is more inclined, it means it is more inclined at point D and less inclined at point E. So let this is point E here. It means we have to make line like that. Here it is more inclined, this is negative slope, this line have negative slope. So first condition is satisfying it. Now second condition is slope is decreasing in magnitude from this point D to E. So this is slope. This is more inclined at point D, less inclined at point E. This inclination is decreasing. This will go like that. This inclination is decreasing. Here it is more inclined. It means here is slope more, here is slope less. So we have to draw more inclined line here, then we have to decrease slope. So it will be like this. This is 6 pound at this. Here is more inclined, here is less inclined, here is very less inclined. So this is shear force diagram for this question. Now we have to draw bending moment diagram. Let me draw bending moment diagram. Now we will draw bending moment diagram. So for that we have to analyze shear force diagram. Let me first find values of bending momentum. At point A, if I draw sectional line which is very close to A and find bending momentum. Bending momentum is force into distance. Here force is 4 and distance is 0. It is passing through this point. So here will be bending momentum only due to this bending momentum which is given, that is 60 pound-feet. So bending momentum at A will be 60. This is trying to rotate beam in upward direction, so we will take this as positive. So bending momentum at A is 60. I will write here 60. Now at this point, which is 2 meter, this is 2 meter away from this point, this support A, shear force is 0 at this point. It means what is shear force? Shear force is slope of bending moment diagram. It means slope of bending moment diagram will be this 0 at a distance of 2 meter from support A. So it will be like this upper point. So this slope is 0 because it is, if we draw tangent here, it will be horizontal. So when slope of bending moment diagram is 0, it means bending moment is maximum here. So we will find bending momentum at this point. So it is at a distance of 2 meters. So we will make sectional line here. So bending momentum will be due to this, it is 60 plus this force will try to rotate beam in upward direction. So force is 4 and distance is 2 meters. So this will be 8 minus this due to this uniformly distributed load. So this will be 2 into 2, that is 4 Newton magnitude, and it will act on center. So this will be 1 meter from this distance. So this is minus 4, which comes out to be 64. It means bending momentum is 64 here at a distance of 2 meter. So let this distance is 2 meter, this is 64 here. So I will write 64. Now at point B we will find bending momentum at point B. So we will draw a sectional line which is close to point B. So due to this force, this will be plus 60. Bending momentum at point B, bending momentum at B will be 60 plus this force into distance is 10, that will be 40 minus due to this force, due to this uniformly distributed load. And so we will draw point load instead of this of equal magnitude, and it will act at the centroid of this uniform distributed load, so that is 20, and this distance will be 5. So we will write here 20 into 5, that is 100 minus 100. So this is momentum at point P. We analyze this side, so this will come 0. So I will write here 0. Now first we will draw bending moment diagram for this up to point B. Here at point A this is 60. Now at point this is 64. Now we know value, we have to determine slope. Now this is on the upper side, we have to analyze. For this we have to analyze shear force diagram. So shear force from this point A to, let me say this point Z, from A to point Z shear force is positive because this is on the upper side of this x axis. So we will write what is shear force. Shear force is slope of bending moment diagram. So we will write slope of bending moment diagram equals to positive from this point A to point Z. A to Z, slope of bending moment diagram is positive, and this shear force is decreasing in magnitude. So we will write here slope of bending moment diagram is decreasing in magnitude. So how can we draw this? This slope is positive, so this is in first quadrant, and from A to B it is decreasing. It means at A slope is more and at B slope is less. So it will be like that. Here is more slope than, because here is more inclined, here is less inclined, so here is less slope. But this is in first quadrant, so slope is positive and it is, this magnitude is decreasing. So we will draw here like that. This is less inclined here, here is inclination is more, so slope is more here. So if you draw tangent here it will come horizontal, if you draw tangent here it will come with some slope. Now we will find bending momentum at this point, at point B. Bending momentum at point B, we already found this. This is 0. Bending momentum at point B, this is 0. So I wrote here 0. Now we know value, we have to determine this slope of bending moment diagram. Now if we analyze from this point to this point B, shear force diagram is negative. It means our shear force diagram is slope of bending moment diagram. It means slope of bending moment diagram, SLOP. We will write here slope of bending moment diagram from this point Z to B will be negative, because shear force is negative and shear force is increasing in magnitude. So you can see this is increasing in magnitude from this point to this point. So we will write slope of bending moment diagram will be increasing in magnitude. So this will be like that. Here is magnitude 0, here this is more inclined, this is more inclined, and this point, this slope is negative but inclination is more. Here this point slope is this negative and inclination is less. At this point this is 0 slope. So this is up to B. Now in order to draw further this, we will find values. We will find bending momentum at this point. So how can we find this? We can find this force. We will analyze this side. So this will be 60 plus this force is 4 and distance is this 10, 16. It will be 4 into 16. 4 into 16, 64. If you will calculate this, it will come this minus 96. I will direct write this value because in order to I want to save your time, so I will write here at this point this will be bending momentum will be minus 96. So I will write here this is at a distance of 16 meter from point A. So this is 16 meter and bending momentum is minus 96. So I will write here that this is minus 96 and this is here minus 96. Now, now we are analyzing from this point, from this 10 feet to 16 feet. So from 10 feet to 16 feet, this shear we have to analyze shear force diagram for this. Shear force diagram is negative. It means from this point to this point, our this bending moment diagram will have negative slope, but shear force is constant from this point to this point. It means it in our this slope of bending moment diagram will be constant but will be negative slope. So I will write here, so slope of straight line is constant, so I will make a straight line. This is lying in second quadrant, it means it is slope is negative. And this point C, if we find bending momentum at this point C, it will come minus 180 at this point C. So I will write here that this is minus 180. So you can find it easily at point C. This is point C. So you have to draw section here, either you have to analyze this side or this side, so you can find it easily. So I am just writing these values now. Now we have to draw showing this bending moment diagram from this point to point C. So you can see from this point to point C, this shear force diagram is negative. It means slope will be negative and shear force is constant. Shear force is also constant. It means our slope of bending moment diagram will also be constant. So I will write here this is minus 180. So there will be difference in slopes because here is one value, magnitude of slope will be 1, here is another value, magnitude of slope will be another, this will be more. We are not drawing this exactly with scale, so there may be some errors. Now at point E, shear force is bending momentum is negative 0. So I will write here bending momentum is 0. So bending momentum is 0. So how can we find this? If you draw a sectional line here, either you have to analyze this side or this side. So we will analyze this side, it is very easy. So it is force is 6 into distance is 0. So bending moment will be 0. Force into distance, that is 0. So this is 0. Now you can see from this point C to point E, shear force diagram is positive. It means slope of our bending moment diagram will be positive. So we will write slope equals to positive. Now this shear force is more here, here is more, here is more, then it is less here, here is less, here is very less, here is lesser. So it means our slope will be positive, but it will be decreasing in magnitude because shear force is decreasing up to this point. So we will make a line from this point, this C to E, which have slope positive. Slope will have positive and magnitude of slope will be decreasing. So how can we make this? So slope is positive here. This will lie in first quadrant, but slope is this magnitude is decreasing. It means our slope of bending moment diagram is decreasing. So how can we draw this? So we can draw like that. It means here slope is more, then it is less inclined here, here it is less inclined. So slope is more here. This is in first quadrant, it means our slope is, so we will draw like that. So this is more slope here, here is lesser, here is lesser. So you can draw like that, but slope is positive. This is bending moment diagram and this is shear force diagram. Now try this question again by yourself. Hope you understood this. Thanks, have a nice day.